Hello everyone. In this video we're going to be solving a very interesting exponential equation. We have x to the power x equals square root of 2 to the power negative square root of 2. And we're going to be solving for x values. I don't think this problem has been solved before. If I'm wrong, please correct me. Alright, so we're going to be looking for the x values, but we have a really nice function on the left hand side and something similar on the right hand side. The problem is we have a base and an exponent, but on the left hand side we kind of have like the exponentiation twice, or kind of like, so this means x to the power x, and that becomes the exponent for x. Make sense? So here is what this means. Because if I wanted to write x to the power x, you know, something like this, then obviously this would equal x to the power x squared. So we would write it that way. Anyways, it's understood that way. Let's go ahead and try to find the x value from here. So we're going to be looking for the x value. I'm going to be working on the right hand side. So I'm going to simplify it. And then at the end, I'm going to show you a graph of it. All right, great. So what can I do on the right hand side, right? When you look at square root of 2 raised to a power of like something like negative square root of 2. Okay, so first of all, I'm going to write the square root of 2 as 2 to the power something. So let's start with this one. I'll write the square root of 2, the base, as 2 to the power 1/2, and then raise it to the power negative square root of 2. All right, great. Now, let's go ahead and distribute. It's kind of like a power of a power. So this can be written as 2 to the power negative root 2 over 2. And then now, I would like to write this with a positive exponent. And you know, negative exponent, if you have something like a to the power negative x, it can be written as 1 over a to the power x, as long as a does not equal 0, you know, so on and so forth. So let's go ahead and do it that way. We can basically write this as 1/2 to the power root 2 over 2. Now, I made the exponent positive because we do need something like that. Now, let's go ahead and work on root 2 over 2 a little bit, so that we can kind of make this expression look like x to the power x. Okay, here's what I'm going to do next. I'm going to write the root 2 over 2 as 1 over root 2, because they're equal, right? Remember, most of the time we're going to be rationalizing denominators. In this case, we're kind of rationalizing the numerator, because that's what we need. Anyways, so I'm going to write this as 1/2 to the power 1 over root 2. I mean, you don't have to do it, but I think, in my opinion, it makes it a little easier to convert. Anyways, so now what does 1 over root 2 mean? It just means that it is the square root of 1/2. So I can write this as square root of 1/2. And as you know, if we have a, you know, positive quantity and it's square rooted, then we can write it as something to the power 1/2, right? So in other words, square root of a can be written as a to the power 1/2, as long as a is greater than or equal to 0. Okay, so then I can basically write the square root of 1/2, which is the exponent, as 1/2 to the power 1/2. And this is the critical part, because now we have on the left hand side x to the power x, and the right hand side is 1/2 to the power 1/2 to the power 1/2. Great. So now this means, or this indicates, that x equals 1/2. And of course, a good question to ask at this point is, obviously x equals 1/2 satisfies this equation, but are there any other solutions, right? So how can you tell? Well, if you can manipulate the exponent on the right hand side in a different way so that you can get different numbers, obviously that's going to be a solution too. But you can also look at it from a calculus perspective. So let me tell you a little bit about this. I don't want to keep it too long, but here's the idea. And then I kind of fast forward. So if you have an expression like this, you can ln both sides, obviously. Now it's going to give you x to the power x times ln x. And then you can ln both sides again. That's going to give you ln of ln y. And then this is going to be ln of x to the x plus ln of ln x. Obviously, we're using some logarithm rules here. And then, of course, this is going to move to the front, and then we're going to get rid of all the exponents, and we can just differentiate both sides with respect to x, remembering that y is a function of x. So we're going to use the chain rule here, so on and so forth. And fast forward, you're going to get something like this for the derivative of y. The derivative of y is going to look like x to the power x to the power x, multiplied by x to the power x, multiplied by ln x, and all of that is being multiplied by 1 plus ln x plus 1 over x ln x. That's a long process, so I'm going to skip forward to that, and I want to show you the graph of this function. Now, what does the derivative tell you? Well, if the derivative is positive on a certain interval, then your function is going to be increasing. So here's the graph of y equals x to the power x to the power x. And here's the intersection point, or a point on the graph, I should say, whose x coordinate is 1/2, and the y coordinate can also be seen here, which means that x equals 1/2 is the solution to our equation, and that happens to be the only solution. If you happen to find another solution, please let me know in the comment section. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.